Hello and welcome to our today's webinar, Mobile Mapping with the Navis VLX, When Speed Meets Accuracy. This webinar is going to be recorded and you will receive an email with a link in around 24 hours. Every participant is muted. If you have any questions, please write them down in the question box and then we will answer them at the end of the webinar. The webinar will look like the following: that my co-host, Dr. Lawrence Lachauer, will be will present the VLX and the workflow with it, and then I will take over and show some things in PointCap so you can understand the main workflow, and then we will go over some topics regarding questions, answer your questions, and so on. Let me introduce Lawrence a little bit more. He is the head of solutions at Navis, and he is working for Navis now for around 2.5 years. Before that, he was at Nemetschek, a product manager for Allplan, and he did his PhD in computation design and form optimization at the ETH Zurich. And with that, Lawrence, the stage is yours.
Thanks, Martin, for this kind introduction. And thanks a lot, actually, to Martin and to PointCap to host this webinar together. It's a great pleasure. Today, so as Martin announced, I will now take a few minutes to walk you through the Navis product offering and there specifically the new VLX. And from there, we then basically, Martin will then basically take the output of the VLX and will show us what you can do then with PointCap based on the data. So, let me briefly discuss basically the history of scanning, of digital scanning. So in the 1980s, basically the digital total stations appeared on the market. What you could do there basically is to capture one position, from one position several points. And obviously total stations are always still today used a lot. But basically very soon, basically in the 2000s, basically another device entered the market and now nicely complements basically the total station. And these are the terrestrial laser scanners. And those basically, they are also stationary devices. So usually, so you operate them from fixed points. And compared to the total station, now you can capture millions of points from one position. But obviously, this is then in a subsequent order done from several multiple positions, depending on the project. And then in the 2010s, 2015 here with the first Navis device, basically mobile mapping became a thing. And what is now the fundamental difference? On the one hand, obviously, that you can move the device. You're not fixed to certain, let's say, points. But also from a technical perspective, there are some really interesting underlying principles here. And let me briefly highlight a few of them. So now you're not basically scanning from individual positions in points in time, but you're rather doing a continuous scanning. So basically, you have a millions of, in each second, basically, you have another scan of the environment. And what this changes actually in the underlying technology is basically that now the quality of the data is much more dominated by the software compared to earlier basic devices, terrestrial devices, terrestrial laser scanners, but also total stations. There, mainly the sensor quality itself is dominating, let's say, the point cloud quality. Now, with mobile scanning, and this is not obviously not only Navis scanning, the software component is, let's say, the most important factor for the quality of the output. And to make this a bit more vivid, let's say, I like to basically bring the comparison here to cameras, right? Remember, basically, the professional digital cameras, they are also mainly, the quality is mainly determined by the optics and then by the sensor size, right? And this is comparable, let's say, to terrestrial scanners. While now, basically, mobile devices are able to take photos with surprisingly high quality, although they have a much, let's say, a much worse optics, because basically, again, also here, the software is becoming the dominant component. So for you, it's just important that basically we are in the shift from, let's say, terrestrial scanning towards mobile scanning. We are also shifting from a hardware-dominated product to a software-dominated product. Obviously, also the Navis products, you have hardware there. Yeah, you hold clearly a piece of hardware in your hands, but in the end, the magic is the software.
One step which I'd like to add here is the reason why we are going from terrestrial laser scanning to mobile mapping scanning is in fact the time you need on site, which is reduced immensely if you use a mobile mapping system instead of a terrestrial scanner.
Exactly. The benefits, I will just highlight them in a second, Martin, but thanks for reminding.
Sorry.
So basically here, what we see here, basically the product we will look at is the Navis VLX. And before we do this, basically, we have to remind ourselves that basically in all those disruptive processes or the disruptive phases in markets, basically you have people that adapt basically to new technologies faster than others, and by this basically become winners in the whole play. And there we see, for example, one of our partners that are operating Navis devices, Mark, he points out basically the speed of mapping, where you can usually you have above 10 times faster in average scanning per area with Navis mobile devices, but in some cases even much more, like 30 times faster, as we see here. But then not only there's a technical advantage, but this technical advantage actually brings the possibility to grow basically the business significantly. And we have here one example from Martin Oberzaucher. He's the head of Vermessung Schubert. We have also on the Navis website actually a nice video case study from, especially when they use VLX, because basically Vermessung Schubert has been one of those beta testers of the earlier versions of VLX. So basically that you can see on our YouTube channel when basically how the VLX looked before it got launched and what Vermessung Schubert has been able to do even with the prototype. And then, and then obviously also the topic of the quality of the data. Now, let me introduce to you briefly the product line, the Navis product line. So we had an earlier product, basically that is still that we still produce and is a complement to the Navis VLX, the Navis M6. I will not go into details of this product today, but it's, let's say, suited for very large spaces, so above 5,000 square meters. While the Navis VLX is much more versatile, let's say, so you can use it especially also in areas where basically wheels cannot be used nicely, so in construction sites, but also staircases, etc., also smaller rooms, and smaller projects in general. And then basically with this, there comes on the one hand processing software, but then also the Navis Indoor Viewer and Navis Cloud that allows you basically to access all the data and view the data. Let me give you a very brief overview about Navis VLX as basically a game changer here. So what we see now is a point cloud scanned with Navis VLX here in the Deutsches Museum in Munich, basically a prestigious technical museum. And we highlight, we will just go into all those feature details in a second. Basically, we have the cameras, the SLAM basically as the software component, and then the live interface. I'll highlight a few of those later still. And then basically also, especially compared to the M6, we have a much more compact design, while the M6 still is coming in 4 boxes. Basically now the VLX really fits into one. And now you see basically the operation of the device, basically on your shoulders walking, and this gives you basically this very comprehensive point cloud. This is basically another benefit of mobile scanning in general, that you get much less occlusions compared to terrestrial scanning. Good.
You just said that the VLX comes in less boxes. How big are these boxes? Can I take the VLX directly as luggage on a plane, or?
It is working as luggage indeed. Unfortunately, at this point, not as hand luggage. Yes, we are. That is, we did. At the moment, we are still on the range of check-in luggage, or sometimes, depending on the airline, also bulk luggage. So we're kind of at the border there. But it's one box and fits in every car.
How much does it weigh?
The device itself is 9 kilos. So what you have on your shoulders, like a backpack, let's say a hiking backpack, and the whole device with box, etc., it's 25, a bit above 25 kilos.
Okay. Sorry for interrupting.
No, perfect, Martin. Whenever you have a question, jump in. So basically here we have the one remarkable feature in the whole design is basically the whole camera head, because it's designed such that it's above the operator's head, and this makes sure that basically all the panorama pictures we are taking while scanning, they are basically, we remove automatically basically the operator. So you have an obstacle-free viewing of the facility. And these are in the VLX 24 20 megapixel cameras, which are then stitched together to 360-degree panoramas. Then we, in order to carry the weight, on the one hand, basically you have those shoulder rests, so you can even use your hands free, but the main weight actually is on the waist belt. Then we have two batteries here, which last, basically the whole package comes with 4 batteries in total, and a pair of batteries lasts for 1.5 hours, and you can hot swap them.
How long does it need to recharge them?
The recharging that is actually a very good question. I have to double check it in a few seconds. While you will present PointGap, I will double check the recharging. Besides this, obviously we have 2 laser scanners, 2 LiDAR modules that have a maximum range of 100 meters, and those are used both to generate the point cloud and for running the SLAM algorithm. Here, as you have seen before, basically the possibility to collapse the device, basically to fold it, to fit it into a box. And then here also the live display, which gives you live feedback where you have been already. And this allows you actually to be sure that you have captured everything on site, not to have basically surprises that there is basically a gap in the point cloud after you're back in the office. And then this is an important feature that we introduced actually with the M6 array, or with the M3 even, and now also is there on the VLX, is basically the possibility to use control points. These are, for example, surveying targets. You can use them, you don't have to use them, but especially if you have projects that are so large that you need to create several data sets, because usually we recommend to have one data set not longer than 60 minutes of a scan. So if you have a really huge project with multiple data sets, then we suggest to use control points, because then the alignment can be done based on those control points. And another possibility is that, especially also for really large projects, that you use those control points that have been measured before with a total station. And then the processing software of Navis allows you actually to optimize the global point cloud geometry to those control point coordinates that you know from having them measured basically with a total station. So this is the twofold application of control points.
So that means if I'd like to merge two different projects, I don't need to measure these control points with another device like a total station, but I just put them on the ground. I think measure 3 or 4 of them in an overlapping area, and then I'm good to go to merge them.
Yeah, so basically, in this case, there's even another possibility. You can also use basically classical cloud-to-cloud alignment functionality that we also have built in the InnoViewer and processing software. So this is really the control points are really mainly also for registration in a local coordinate system. If you have a specific coordinate system, for example, if the client asks you to deliver the point cloud in a specific coordinate system, then you would measure those with a total station, and then this allows you to register those. If it's pure alignment without the need for a specific coordinate system, then you could even use cloud to cloud.
Okay, all right.
Good, then let me continue. Good, let's now have a look at the data. So what we see here, this is actually not a photo, but it's really the point cloud that comes in this case of the Navis office from outside of the facade. And now let's have a look at the same point cloud from a slightly different perspective. A point cloud of a technical room in this case. And you see actually also the coloring is really realistic because of the high quality panoramas and also the high number of panoramas that we usually take. So this really ensures very realistic coloring also. And then here we see basically the Navis office also as a point cloud with basically sliced off ceiling. But not only the visual quality in 3D is really good, we think, but actually also if you look at the point cloud rather from an analytical section perspective, and here we already used PointCap to analyze basically the quality of the data. So what you see here, for example, on the very left is and are two elevator doors, and you see even basically the small frames basically covering the door frames. You see very nicely in the section, and obviously the overall shape of the elevator door very well. In the second image from the left, you see basically a staircase with a handrail, then basically a door frame in a horizontal section and a door frame in a vertical section with all kinds of details. In also the small difference in height in the floors of those two rooms. Now let me go one step further. One question that we obviously very often get is actually what is actually the accuracy of the VLX. And the whole question of accuracy related to mobile mapping is not an easy one, because in the end, at the moment, we don't have really hard industry standards how to measure those. So that's the reason why basically every mobile mapping provider is also coming up with kind of their own ways. And we are now basically, we have developed a few ways actually how to evaluate the accuracy of our devices. We have a specific, basically separate publication on this on our website, a mobile mapping accuracy handbook. So that's worth a read. And we will have a very soon, I think still this week, we will publish a very similar paper specifically for VLX data and for more use cases. What we state in the spec sheet is that we have basically an 8mm accuracy at sigma 1, so with 68% confidence, which we usually validate and test in a 100 square meter room internally. And then the absolute accuracy, this is basically if you measure not only the distances within one room, but rather if you scan a whole, let's say, project or a whole floor, and then really measure distances which are beyond several rooms. So for example, one corner of the building to the other corner of the building, so which you would not be able to scan from one position. This we basically study in case studies at the moment, but also the results are actually very promising. So we also achieved basically an 8mm at sigma 1 and an 18mm at sigma 2, so at 95%. So what you also see, and this is also what you will see from the new white paper, that the 8mm at sigma 1 for the local accuracy is already a bit on the conservative side.
So if we put that in perspective to terrestrial laser scanning, this would mean that the local accuracy, which you mentioned on the left side, the 8mm, would be equal to taking one terrestrial scan where you don't have a registration at all. You take one scan in which you measure, and normally at a terrestrial scan, this is around 1mm, I guess. But more interesting in this case is the absolute accuracy, where you have with your sigma 2 around 2 centimeters, which would be for a terrestrial scan the registration itself. So if you scanned the complete building, it would be the complete error propagation from the first scan to the last scan, which normally lies in somewhat the same area, depending of course on the registration itself and how well you scanned, where you placed your scanner. But in my opinion, often the numbers are somewhat equal.
Exactly, and that is also what we think is remarkable. Obviously, and also it's explainable because in the end, the whole algorithmics that's behind basically the SLAM that basically brings one consistent point cloud from all those scans is actually optimized to really do the perfect on-the-fly registration, let's say, of those millions of individual scanning points. And in this case, we even have to say basically the example here of the garage is also used without control points. So if you would use measured control points, then you are still able to squeeze out a few millimeters of accuracy for both values.
Okay, perfect.
Good. Then let me continue here. Then let's have a look at the workflow. And now we're actually already fairly close to basically point cap. So how is it working with Navis? So basically with the VLX or with the M6, you scan the environment. Then you basically use the Navis processing software to create basically data that can then be published and upload to Navis IndoViewer or Navis Cloud, where you can on the one hand view the data, mainly also in the panoramas, but also the point clouds. But the panoramas offer actually the possibility to also have people that are, let's say, not very surveying or engineering close to work with this digital representation. And then based on this, you can then select in the interviewer even a piece of the point cloud and download this to then use in all kinds of third-party solutions. And this time today we focus on what you can do then with this point cloud in PointCap, as mentioned obviously before. I would like to hand over now to Martin, but before that, maybe I show you still in a second basically the interviewer, because I have this here, but maybe before the interviewer, even if I can just show you or later I will show you basically where you get the data that also Martin will use. Let me just show you briefly the interviewer. So here we are in the Navis interviewer in a panorama image, and there, so you can now basically this is a factory. You can walk through this, right? You can basically, wherever there is a panorama, you can step to, and then based from this view, you can, if you have the relevant access rights, let me just get rid of this one. So then you can also select here in all in the browser, all without basically installing anything. You can select a piece of a point cloud here, for example, a machine or something, and then basically use this even in 3D, for example, like this, to then download this as a, for example, E57.
And so practically you have your own Google Street View with your created data, and you can measure in it very accurately.
The measuring is a good point. Thanks, Martin. I did not even point this out. So yes, you can also directly, before even using the point cloud, you can also just measure distances. This is definitely possible. Basically, what you see here, we have the possibility to use a oops, sorry. Something seems. Oh no, take obviously the distance. Then you can choose accurate, basically a certain piece of this, for example, here. Then measure specific distance. I admit I'm not perfect and here, but it actually works very well. And we also did actually an evaluation of the accuracy that you can achieve with the interviewer itself, where you basically have the layer of panoramas on top as a blog post, or if you're interested in basically how close can you get to the, by just measuring without using the point cloud, by just using the interviewer. Good, and now basically I will hand over to Martin. So basically just Martin will use a point cloud from us, right? And also if you're interested to use the same point cloud, you can go to download sample data on the VLX page, Navis VLX, download sample data, and then basically you get a selection of point clouds to play with.
And we use here the Office third floor, the 0.8 gigabyte file.
This is the one that you used, right?
Yep. Cool. All right, then let me grab your screen. I have to put myself to be moderator first.
Yeah.
And then I need to share my screen. This one. So now you should all see my screen. Looks good. So practically, I will give a very short overview how you use PointCap. Perhaps one word before even starting here. How is Navis and PointCap at all working together? So in short, we have a cooperation. It started as a marketing cooperation, but it became a little bit deeper in regards of data management and processing. And if you are buying, for example, a VLX, then you're able to purchase our software or other software packages which have a collaboration with Navis at a special price. But now let's talk a little bit about Navis. Lawrence, if you have any questions, just interrupt me. But what we want to do is we want to import a point cloud file first, which is coming from Navis. So I click on New, and then I click on Open Scan Data to choose the scan data file. We have here an E57 file, which is the one you can download from the website. I click on Open, and then normally it should automatically detect that it's coming from Navis. Because it was cropped in Cloud Compare, this isn't happening. But normally, if it's coming directly from a VLX or M6, then Navis Scanning Project will be chosen. And
maybe one comment. Martin, thanks for pointing this out. And we're actually working on basically fixing this minor issue of the demo data, which is basically something like an additional predicate in the in the data that we provide via our website.
Perfect. And afterwards, you click on Save To. You choose where you like to save your data. You can give a project name. I'll just use the one which is in the point cloud, and then I click on Save. And now PointCap will start to import the E57 file and create the PointCap project file format, which is the same point cloud, but it is compressed. So it's a little bit smaller than the E57 file. So after importing it, you're able to, for example, store the E57 file, or if you don't want to use the E57 at all anymore, you can delete it, because then you have the PointCap file, which is a lot smaller. After the import finished, PointCap will start to automatically create 3 standard views, which is it doing currently here. One of the standard views is from the top, and 2 from the sides, 1 from the front and 1 from the left. And in these standard views, we are normally completely working and doing everything. What do you see here as well? You have here all the tools which are in PointCap available. If you can't figure out what the different signs should say, you can click on modules and read the names, and then it's a little bit easier at the beginning. You see on the right-hand side at the bottom, you see the job list. There will be created an element per tool which we use. And then we have here the job editor, where we can change all our properties of this created element. As an example, the workflow looks like that. I just click, for example, on layout and section. Then I say, okay, I'd like to create a section directly here. And I click 1 time for the first point, a second time for the second point. You see here the red dashed line, so perhaps we can set it a little bit more that it is directly on the wall. And you see in the job list directly we have created a section. And if we have selected this, the job editor is filled with these things. You can change here the coordinates X, Y, Z, the clipping range, so which you can adapt here, which then changes here as well directly. You can flip the direction in which PointCap will look onto this section. You can change the scan positions if you have, for example, a terrestrial scan used. You can change things for your cut output, and you can change here which files you like to write. So we are writing automatically a DWG DXF file. And if you want to process that, after creating it, you just press on the green play button and it will start to process that. and we'll take the point cloud and generate an orthophoto out of that. And if you want to see that in PointCap directly, you just double click it, and here you see that. PointCap is using as a standard an X-ray view. So the more points are above each other, the darker we shade the pixels. If there are no points, it's white. If there are some points, it's gray. And as you can see here, for example, the doors, of course, we have some points behind each other than we have at a wall. So we are able to distinguish the things very clearly. If you want to create not a section, but a floor plan, you use the same tool, but you use it in the front or in the left view. So we can just set that here. We can change here the size. Perhaps we want to have any doors or windows in there. So we put it very high and make it a little bit smaller. And again, I just press process and it will run and create the stuff here. If you want to have this section here, which we have created here, perhaps as color, I can duplicate it at the same position. Let's call this color. And all I need to do now is in processing, turn on the color. And of course, while this is processing, you don't have anything where you need to stop creating elements. You can just go on and process in the meantime. And here we see the colored orthophoto. So there you have the context, there you have the color information coming from the VLX directly.
There's even some confidential information on the whiteboard.
What? But I can't read it. So what we have done here is we created all these elements and we directly exported them as a DWG file, right? So we can open this in AutoCAD directly, and the location where we created these photos is completely correct. So the height where we created this, if you check here the coordinates, is at 1.596 meters. And this is directly the height, which you can here see as well, where we created, where the red dashed line is. Of course, we can import the other generated orthophotos as well. So now I think I have to browse there. Open. So let's take the colored section. And I don't specify anything. And here we have the colored section, which is again at the complete right location. And we would be able to start drawing here our lines there. But of course, you can do the vectorization in PointCap as well. So let's look back here. And of course, you could use here the vectorizer lines and here click everything yourself, which is a little bit of a hassle. So normally what you can do is the first thing, you can try to find the lines semi-automatically. And then you clean that up a little bit. For example, you see this is not connected. So we use the connection tool to connect these. You see these are not connected. So we make both lines longer and intersect. And if you have cleaned that up and are satisfied with the result, then you can export that and, for example, insert it here directly as well and do the remaining stuff you need to do. So you can see it's directly again on our layout. So we have the layout created for context, and now we can do the vectorization there as well if we like to. But that's
Martin, if I briefly may jump in here. So from my own experimentation with PointCap, which is actually a pure pleasure to use when comparing it to the, let's say, more old school style CAD systems. But one thing that I realized is that it also improves, I think, the drawing accuracy quite a bit. Right? Is this true, or is it?
Yes, it is true because I mean you have here, if we look here, you have the, let's delete this line here. You have here your point cloud itself, and I mean if I turn off the anti-aliasing, you see here that some pixels are shaded a lot darker, and therefore you're able to estimate where the most points are above each other. So the noise of the scanner and the noise which the Navis software was not able to reduce or get rid of, so the remaining noise. You can see it clearly here in the data because here you have it, but therefore you are able to draw a much more accurate than using the point cloud, because in the point cloud itself, of course, you have the issue. If you pick one point, it could be a complete outlier, right?
Yeah, exactly. So I had the feeling that actually I did some manual drawing basically on top of the, or as you would do maybe in CAD. It seems that your results are much better when you use vectorization first and then do basically cleaning up as you showed. That's my feeling.
But of course, what you can do as well is you can create single lines and use the snapping function by pressing Alt and letting Alt press. You see here that, of course, I need to edit this. And here we have already a line, but then you see that I can snap directly here, and I don't need to create all the line, because afterwards I'm able to connect these just by using this tool here. So of course this is possible as well.
Yeah, that's nice.
What I wanted to do was giving a small overview over the ForRevit plugin as well. I don't know if I should do this with the time, but perhaps let's do this. So let me just do this very quickly so people can see here the workflow as well a little bit. So the idea with the Revit is that you have the point cloud and point cap, and you give Revit just the information where things needs to be created. So you see here the workflow. We create levels, then walls, and then insert windows and doors and other stuff. So let's create 2 levels first. We have, of course, the floor itself, and we have only the ceiling here. So these 2. And here, what I need to do is, let me put this there. We need to turn on the ForCAD button, and that's all. Now we are connected, and I'm using only the 3D point tool for everything. So I just click on the floor itself. I hope this wasn't too loud for you. And one time on the ceiling. And now the levels are created with a height, which you see here as well. So next thing would be we create walls. So I can here type in which type I'd like to use. Perhaps I should go into another view so you can directly see that. So I click on create wall, and let's use this room here. I go into clockwise through all rooms, or through this room. And this is, of course, closed. So I can click on close, and you see these are directly created in the same area. And now, as a last step, perhaps we insert a window and a door. So there are 2 ways. One is we create a section at this position. Of course, now we need here this. Let's do a colored one. Or the other possibility is we create a virtual panorama. So we create it at this location. So we are creating our own panorama here. Let's take only 10 meters distance and put a nice background there. So now we have, for the one, we have here the section where we can see the image and the windows very nicely. And yeah, the panorama can calculate while we are doing this stuff here. So let's look from this side here. We insert a window. We say, okay, we'd like to have this window here. Again, I use this tool here, and then all I need to do is press where the window should be inserted. And there we have our window. Or if we'd like to use this created virtual panorama, I have to open that with the panorama tool. There we see the area as the panorama. So let's insert a door here. So this is a door with one opening, and we just click at the locations where the frame is. And then we need to define the opening. And there we have our door. And perhaps as a last step, if we want to check if the room is all right, we can again create, for example, a layout. If I press F10, it will calculate. And there it is. So we can add that. If we like to, we can bring in other data like from a point cloud. So again, let's create
Martin,
here.
may I briefly interrupt you at this point?
I'm super fast. Nobody is following me anymore and can understand what I'm doing.
No, if you move, yeah, the table over, and then I still have a question with the panorama because I think it's pretty beautiful.
So last thing is, of course, you can export parts of the point cloud in other file formats as well. In this case, of course, we are using Autodesk products, so we go into recap. And I bring in here this part, this table I'd like to bring into my Revit. So I let it process. It will be converted into an RCP file directly in PointCap. And then I have here my cloud export. I can click on plus. And in the 3D view, the point cloud is here directly visible. All is at the right location, and you have more context to your drawing, as well as here your layout, which I have. I don't know why this is under my point cloud. I think it's because of the views. Let's get rid of this one. So now we can see here our created room. And of course, we need to adapt the sizes of the walls because they are definitely not right currently, because I use this standard wall size. But Lawrence, now please your question.
Okay. Sorry. Basically, I think this is remarkable what you showed here. So just one question for understanding. When you picked some points in PointCap, has there been a underlying, let's say, snapping functionality? It looked like it, but I'm not sure. So basically,
there is none yet. So I mean, we want to bring it into the next version. So if you have like this floor plan where you can snap to a very clean area goodly, then with the 3D point tool, we are trying to snap to it after with a new version. But currently the snapping is only in the vectorizer and nowhere else.
Okay, but in the 2D version there you had something like this, right? Because there you followed basically a
I mean, it's these points you have to click very, very carefully yourself. So you zoom in, and where you click, you will create the point, and then this point is transferred over to Revit. So you have to be a little bit cautious where you click, of course.
Okay, cool. Thanks. Maybe just another question, because actually today I had a call with one of our Navis clients, and they said basically they are also looking into Archicad, and since Archicad is also a Nemetschek company, so I know the question is things, at least the vectorization, and to what extent do you plan to also support other software vendors besides basically Autodesk with the workflow that you showed?
For all CAD systems, you practically can use the first workflow, which I just showed for AutoCAD. So you get everything is in DWG, DXF, Collada, so you can import it in SketchUp as well. So this is definitely possible. If you like to have a plugin, this is currently only available for Revit and for Archicad. So we have it already for
Archicad. Nice.
And we're currently developing something for BricsCAD for the 3D functionality, but this will take a little bit of time because Corona, was a little bit harsh in that regard to us.
Yeah. Okay, but that sounds great. And maybe just one other thing, because besides that, there has been the question of the recharging, right, that I could not answer previously. Now I basically looked it up. It's 2.5 hours for both batteries full recharge, just for sake of completeness.
Meaning if you buy another 2 batteries, you can more or less scan nonstop.
Yeah, exactly.
All right. Yeah. I think that's my part for showing what PointCap can do in a nutshell. I mean, it was like 20 minutes and it was very fast. So if anybody of the people watching is interested in seeing more, we have other webinars regarding that. You can contact us and have a demo one-to-one. But I'd say let's wrap that part up and directly dive into the questions, right?
Yes.
So let me ask the first one directly for you, which I was wondering, and that is, if I'm looking at a terrestrial scanner, the color information is mapped from the camera onto the point which is measured, right? And with the terrestrial scanners, you always have a little aberration between the color information and the true measured point. Can you, or do you know something how far these are apart at Navis?
So actually we are taking, so the logic is the following. So we take the panoramas and then use basically the panoramas to color. So we don't use to my knowledge, not the laser information, the color information coming from the laser. And since we have, it depends basically a bit on the number of panoramas that you're creating. So you can literally also create point clouds without even using panoramas. But when you basically stick to the suggested 1 to 2 meter, let's say, distance between panoramas, then the coloring is highly realistic, I would say. I don't have a number in terms of how much the color could be off from the reality, but let's put it like this. So especially in the earlier days of Navis, we tended to look at the point cloud always in 3D. So because there we optimized a lot that basically the point cloud looks visually in 3D very good, which is then therefore we needed to make the mapping of the pictures to the point cloud as good as possible. So I would assume we're actually very, very close to the reality there. Because also if you look at the point cloud with the regular number of panoramas, you see actually very few or no areas where this is not matching. But unfortunately, I don't have a number.
Okay, all right. I think nobody will have taken measurement yet, or perhaps somebody is out there who likes to do a bachelor or master thesis.
Yeah.
Okay, then the first questions from the public. Can we attach GNSS
to the VLX?
Right.
This is a question that we received already several times. At the moment, we don't have a direct connection. You can obviously use some GPS or other technology to measure control points, but we are looking into this to understand basically the added benefits and for clients. That it is definitely one of things to evaluate in the next time, actually, to what extent it could be of added benefit, and also is there enough willingness to pay, let's say, for connecting to GPS or GNSS.
Okay, the next question is, can I merge other point clouds from terrestrial scanners, I guess, into the VLX or M6 data?
Yes, you can do this. On the one hand, you can upload point clouds to the indoor viewer, and then you have basically a point cloud of the whole, or that combines both, and then download it. So that would then contain the points of a terrestrial scanner and of the VLX and or M6, or you can obviously use a classical, let's say, point cloud editing tool like Recap and combine basically the point clouds there.
Or you can do the combination if you have the control points, of course, in PointCap as well. I mean, this is possible as well, just saying.
Cool. Yeah, cool. No, I have not been fully aware of that, how to use basic control points and PointCap, but it's great to hear. So.
Next question. In the parking car garage example, is the point cloud averaged, checked where the path crosses each other? So I guess the question is if there is loop closure, if you see the same area again, I'd assume.
Obviously, that's a very important thing I maybe did not highlight enough. So actually, if you don't use control points, then what always is being used is basically internally in the software and in the algorithm, the loop closure recognition. Because in the end, that's, if you don't use control points, that's the only way basically to control also the drift, which is basically an effect that you always have. If you, for example, just map down a straight corridor that is super long, that then you would accumulate error, but you would also accumulate error with a total station, but just on a different level, let's say different scale. But there, the way basically to mitigate this is indeed to basically come back to those points where you have been, if the building geometry allows for that, in the same data set. And then those are being used to zero out error in those points. So it's essential to plan for loop closures when you don't use control points. Thanks for the question, by the way.
Thank you very much. The next question is for the time ratio between measuring and the processing afterwards. So how long is the processing taking time?
So at the moment, so there also, again, we need to add a bit of an explanation. So if you do basically highest, at the moment, what we have discussed and have shown is basically highest quality point cloud and coloring and everything. And this is based on the density of images between 1 and 2 meters. If you have this, and you also create basically from this the package of the indoor viewer, etc., then for 1 hour of mapping, you have around 8 hours of processing. But this can be significantly reduced if you, for example, for certain reasons are not so much interested in the coloring of the point cloud or in the panoramas or things like this.
The next question is for the data itself. I mean, perhaps as a background, there are a lot of people who don't like to upload their point cloud to the cloud and just want to process everything offline. And then there are other people who would like to use their own tools which they produced. So the question is it possible to export the trajectory and point cloud data with timestamps and both in the same time and coordinate system?
Yes, so basically, or let me, timestamps and panoramic images, I think. So basically, when you use the processing software, that, by the way, does not have to run on, basically, you don't need to go to the cloud. You can also do on premise. Then basically, you get also a file with basically the trajectory and coordinates of the panoramic images. So basically you get a whole bunch of potential files that you could use, especially if you then want to do some other stuff with this information besides the point cloud from the processing software.
Is in the point cloud, are there other timestamps there available as well?
In the point cloud itself, to my knowledge, not only on the trajectory, because obviously it also does not fully make sense, because each point in the point cloud usually is being scanned from multiple positions. Imagine, for example, the parking garage. It's constantly scanning, and you scan a point from very often, right, when you come by, and therefore which time to assign to a point, right? So, but for the trajectory, you have a clear timestamp.
All right. I think that was it for the time being, since we are now at 5 p.m. GMT +2. Thank you very much, Lawrence.
Thank you, Martin.
At the people in the crowd, if you have any more questions, please just write us an email to support@pointcloud-software.com, or directly to Lawrence or to I. Lawrence, do you have the screen where our email addresses are, perhaps?
Let me 1 second. So let me share that screen.
Wait, here, now you are the moderator. Now you can share your screen.
Yeah.
So here you see our email addresses again. If you'd like to send us an email with a question, or if you have something else you'd like to discuss with us. And of course, if you're interested in our other webinars, check out our website, pointcap-software.com. At the 30th of June, we will have another webinar hosted by Navis, and please join this as well. And
yes.
With that, everybody have a nice day, and thanks for joining today.
Yes, thanks from my side as well for watching, and hopefully speak to you soon. Thanks, Martin and PointCap.
Bye.